Chapter 13, Sample Problem Number 3. A block rests on a frictionless surface and is attached to the end of a spring. The other end of the spring is attached to a wall. 4 block spring systems are considered. The springs are stretched to the right by the distances shown in the figures and then released from rest. The blocks oscillate back and forth. The mass and force constants of the springs are given in each case, and we would like to rank the frequency of the oscillatory motion. So we don't have a direct formula for frequency, although you can certainly generate one, but we do know that the period for simple harmonic motion is 2 pi times the ratio, the square root of m over k. And we know that the frequency is 1 over the period. So if we get the periods, the ranking of the frequencies would just be the opposite order to the ranking of periods. If we look at the periods, we'll take case A. The 2 pi doesn't matter. Even the square root doesn't really matter because we're just looking, t squared ranks in the same order as t. So I'm really just looking, we're going to look at just m over k. So here we have 1 over 5, and here we have 2 over 5, and then in C we have 5 over 4, and in D we have 1 over 1. So D is sort of our baseline. Notice that we are not making any reference to the stretch because the amplitude does not affect the period and it does not affect the frequency. So the 4.4 meters or the 0.2 meters, that's all just irrelevant really. If we were to order the periods, the ordering for T, we can see that the greatest one is C, and then the next one is D, and then the next one is B, and the next one is A, which means if we want to instead rank the frequencies, we just reverse it. A is more than B, is more than D, is more than C.